We start with a simple cube. The goal is to turn this cube into many smaller separated pieces. First, we add split edges. This separates the faces so each face can behave more like its own piece. To see that it actually works, we add scale elements and set the scale to around 0.9. Now the faces shrink a little and we can clearly see the gaps between them. Without split edges, the cube would still behave like one connected mesh, and that is not what we want. Now we add Subdivide Mesh. This takes each face and divides it into smaller faces. By itself, that already works, but it divides everything in the same way, which looks too clean. So instead of subdividing every face, we add Separate Geometry. We set it to the face domain. Then we use random value as the selection. Now only some faces are selected. Those selected faces go into Subdivide Mesh. The unselected faces are still there, but for a moment they are separated from the main flow. So we add Join Geometry and plug the inverted output back in. Now we have the full cube again. Some faces are subdivided, some faces stay untouched. That already gives us a more interesting pattern, but one pass is not enough. So now we add a repeat zone. The repeat zone lets us run this same logic multiple times. Each iteration takes the current geometry, randomly selects some faces, subdivides them, and joins everything back together. The more iterations we add, the more detailed the cube becomes. But if every iteration uses the same random selection, it feels too repetitive. So we connect the iteration output to the seed of the random value. Now every iteration gets a different random pattern. At this point, the effect works, but there is a problem. If we keep increasing the iterations, the faces become extremely small, and the geometry gets heavy very fast. So we need a limit. We do not want to subdivide faces that are already tiny. To do that, we add face area. Face area tells us how large each face is. Then we add compare. We check if the face area is greater than a small value. If it is big enough, it can be subdivided. If it is already too small, we leave it alone. Now we combine this with the random selection using Boolean Math set to AND. So a face is subdivided only if two things are true. It was randomly selected and it is still big enough. That gives us a controlled procedural effect. We still get random detail, but we avoid creating millions of tiny faces. At the end, scale elements keeps the pieces slightly separated. And that is the final setup, a simple cube turned into a procedural cracked panel structure, with random subdivisions, repeated detail, and a safety limit based on face size. I'm testing this new visual tutorial format, so let me know in the comments if you like it. And if you want to animate these cube pieces expanding outward, check out my index node tutorial. You just need to swap the instance domain to face domain. Also, if you use Blender for client work, I made a small app called Tasky. It helps you track project time, income, expenses, and your real hourly rate. Because sometimes a project looks profitable until you realize how many hours it actually took. If you want to try it, the link is below. And if you sign up with code YESWAY, I will add your name to the early supporters page and include your nickname in the next tutorial. Just remember to set your nickname in the app.